The Laplace transform can also be used to solve differential equations. Let's say we want to solve the differential equation first derivative of y of t plus 4 times y of t is equal to the first derivative of x of t. And x of t, our input signal, is given by sine of 2t times the unit step function. So it's a causal sinusoidal input. And we want to find the output of the system y of t. As a first step, we will apply the Laplace transform to both sides of the equation. This gives us s times y of s, because we have the first derivative of the output signal y of t, plus an initial condition term, which we will ignore here or simply set to 0, plus 4 times the Laplace transform of y. This must be equal to s times x of s, where again we assume that the initial condition of the input signal is also 0. This gives s plus 4 times y of s is equal to s times x of s. Solving this for y of s gives that the output in Laplace domain is equal to s divided by s plus 4 times x of s. To solve this, we have to substitute x of s, for which we know that because x of t is a sinusoidal signal, x of s here is given by 2 divided by s squared plus 4. So that y of s is equal to s divided by s plus 4 times 2 divided by s squared plus 4. We have at least two options to calculate the output y in the time domain. The first option would be to use the inverse Laplace transform, which is given by this integral. However, this calculation is often very hard and cumbersome. It's a much better idea to use known transform pairs instead. We need to write y of s as a sum of a term with denominator s plus 4 and another term with denominator s squared plus 4, instead of a multiplication with two terms with those denominators. Hence, we need to find the coefficients a, b, and c such that those two equations are equivalent. This step is called solving partial fractions. A little bit of math gives us that a is equal to minus 0.4, b is 0.4, and c is also 0.4. So that y of s is equal to minus 0.4 times 1 over s plus 4 plus 0.4 s divided by s squared plus 4 plus 0.2 times 2 over s squared plus 4. All three terms are known transforms of specific signals in the time domain. Hence, we know that y of t is equal to minus 0.4 times the inverse of 1 over s plus 4, which is minus 0.4 times the causal exponential decaying function e to the minus 4t u of t. The second term with s over s squared plus 4 is the known transform of the cosine signal, so that we get plus 0.4 cosine of 2t times u of t. And the last term with 2 divided by s squared plus 4 is again a transform of the sinusoid, such that we get the last term plus 0.2 sine of 2t times u of t. If you're interested in solving this example with non-zero initial conditions, have a look at the script.